Good afternoon. We're here for the MacGyverator assembly video. Thank you all for joining me. It's a rainy Sunday here in the Boston area. It's a good day for building stuff. So what I wanted to do was get started with showing how to put the MacGyverator together. And so the first thing we're doing here is putting together the baseboard. So for the baseboard, we just have any kind of plywood, anything from basically 3/8 to a ½ inch is fine. Can be furniture grade, can be just whatever kind of particle board you have around is fine. It just needs to support stuff, so nothing too crazy there. This is a 2 foot by 2 foot piece that came pre-cut from the big box store, which is really nice. We really only need about 18 inches in one dimension and 2 feet in another dimension, so we're going to cut this to size. And so I've just measured out 18 inches worth here, and I'm just going to rip it. And it should go without saying, but I'm going to say it anyway. Safety equipment, I am a pediatrician. Safety glasses, hearing protection, dust mask if you actually can find one. Okay folks, we have our cut to size base plate here. We got 2 feet in this dimension. This is, we're going to call sort of the long dimension, which is where the compression arm eventually is going to go. And then the bag is going to be eventually laid sideways like this. So what we've done before this is actually cut a bunch of blocks to start things off. And so using just 2x4, I've cut 4 lengths of 4 inches apiece. Now, 2 of these we're going to use for the pivots at the base of the compression arm. And to make these little pivot holes here, basically I made a measurement right in the center of this 2x4, an inch away from the edge, and then drilled out this hole with a 1 3/8 inch spade bit. And what that's going to do is, when you buy your T-fitting, your PVC T-fitting, that fits over your 3/4 inch PVC pipe, just as like a friction fit, just a test. This hole is going to be what fits around that PVC fitting. And you can tell sort of, it's not a super tight hole, and you don't want it super tight. You want this flowing pretty freely or turning pretty freely. And so again, 1 3/8 inch paddle bit that will allow what fits outside of a 3/4 inch PVC pipe to rotate freely. So once you drill these holes, again, right in the middle, smack dab in the middle, and then an inch up from the border or from the edge, you're going to start to lay things out. Now I'm cheating here, obviously. What I've done is I've taken apart one of the prototypes just to reassemble it again, but you guys will get the idea as we go along here. And then these blocks here, I've just cut notches in, just with a handsaw, nothing crazy, to support the bag and keep it from shifting around. As you compress the bag, you do develop some lateral forces here, so you want to have that notch there to help hold things down. And then just along the ends, just some adhesive Velcro. You can, this stuff doesn't stick great, so if you're being thorough, and you should be thorough here, it's advisable to just stick a couple staples in here on each of these sides. If you don't have a staple, you can stick in a tack or a screw or something like that. But you're going to lay this out about like so. I'm going to get my compression arm here. Again, this is a completed one, but you get the idea. We're fitting our T-piece onto a 2 foot length of PVC. What's nice again about the big box stores is that these come pre-cut, but PVC is super easy to cut with a handsaw. You can handle that if you get a longer piece, but 3/4 inch again, doesn't matter if it's electrical grade or plumber grade, whatever. And you're going to slot your PVC pipe into those holes and line it up roughly so that your compression arm here, your PVC compression arm here, is parallel to the edge of your board. And you want to push your blocks here together. Actually, this one I originally had like this. Push these together, not super tight, but tight enough so there's not a lot of lateral play here. Since you don't want this to be able to go way over here, you might miss your bag. So you line things up so that there's a little bit of wobble. A little bit of wobble's fine, but this is still, you can see, flowing or pivoting pretty freely. And once you have that spot, mark off the edges with a pencil. And then you get your bag. All right, so this is just a standard adult size ambu bag. I don't even know what brand this is, but there are different brands. And so you're gonna have to sort of massage a lot of the part of the build here, depending on what kind of bag you have, what the size of it is. But what you're gonna do here is you're gonna lift up your compression arm. Again, nothing is attached here, so you're just kind of trying to approximate the layout here. But you're gonna put things in place as if you were assembling it. About like that, and you want the bag to be supported basically as close to the bag itself as possible, but you also want it to be relatively level, the bag level. You don't want it tilted up or tilted down too much one way or the other. And what you're shooting for now is you want to be able to achieve an angle here from the flat plane of the baseboard of around 30 to 45 degrees. You don't need it to be too steep. That creates issues. You don't want it to be too low, too slack either, because that will create issues later on down the road too. You don't need to have a protractor out at the same time. You just want to be positioning this so that the angle of your PVC pipe is 30 to 45 degrees. And here this is eyeballing about 45 degrees. You want your compression arm hitting roughly the center of your bag. That's going to give you the best spring back and the best compression, the best bang for your compression buck. And so, you massage these around until things are looking good. Check your alignment. And then once you're happy with the way things are, go ahead, pencil, take your carpenter's pencil, and just mark off your edges. And then you can take this all apart and use the stuff that you've marked down to put everything in place. And so you're going to actually go from the bottom side and drill in screws from the bottom. And the screws that I used here, let me find one. Nothing fancy. These are just 2-inch wood screws. These have a Torx head, but you can use whatever you want there. I do recommend drilling pilot holes using like a 1/8 inch drill bit or whatever, just because you want the alignment. It doesn't, like I said, these aren't aircraft tolerances we're building here, but you do want things to sort of stay in place. It is hard to hold this together with your hand or even with a C-clamp and drill up from the bottom. I recommend doing pilot holes with that 1/8 inch bit. It does take a little bit longer, but everything's just going to align much better in the process. Okay, now we fast forwarded to having all our blocks here, all our 4-inch blocks tacked down with screws. As you can see, we have our PVC bar here. Not a lot of play left and right or in this direction, in the short direction of the base plate, but this is still pivoting pretty freely. And that's how that looks like down there. And let's put this together with the bag. I'm going to put this down for a second, hopefully without dropping it. Okay. All right. So my bag is going to go into here, just like that. And you see my my PVC pipe here is right at about a 45-degree angle, just like we planned. I'm going to tack this guy down with Velcro straps. It may or may not matter, but I put the hook side on the wood block here, and I'm using the loop side, which is a little more pliable. And there's less friction here between the loop part and the plastic here, because this thing will move as you compress it. By using the loop side on top to hold this down, and I pull pretty hard to keep that retained there. It's not going to stay still, but we definitely don't want it sliding out. Same thing on the other end. And so, as you see, when this compresses, things move, right? Do that a little tighter. So as things compress, your bag's going to move. all right? It's gonna, both ends, like this is gonna flip up, that's gonna flip up. That's just, you can't avoid that. This is going to get shorter when this gets compressed. So just be prepared for that. And so these Velcro straps help you deal with that. I will point out one thing, which is that on this particular bag, there's a pretty good, hopefully you can see this, there's a pretty sharp shelf here between these sort of levels of the plastic. And so what happens sometimes that I noticed when I was testing this is that when you compress, the bag falls past one of those little plastic shelves, and then it gets caught on the edge of the 2x4 there, and it can't come back up. And so what I did to help mitigate that actually was, hopefully you can see this, I filed down the edge of this notch here just to get a little slope here, a little rounded slope here, so that if those little stair steps do come past the edge of the 2x4, it can just slide back up. It's not a big deal. All right. And again, I don't know what your bag's going to look like, but this is just one of the sort of considerations you have to take in as you're building things. Since we're hacking this together, we're tweaking a bit as we go and trying to predict places where things can break down. And this is also where testing is important. You got to try things out a lot as you're putting things together to see how stuff works and trying to identify where points of failure might be. So one of the suggestions that was given between MacGyvelator Mark 1 and Mark 2 was to add some support here at the bottom of the bag. This was a great suggestion because, as you see, when you push down some on this, the bag is going to sag, and so you're actually losing some potential compression by this sagging. And so all I did was take a block of 2x4 here. This one, as opposed to the 4-inch blocks here, is 6 inches wide, and it fits pretty well in underneath the bag here. And just tack that in. And what that does, it's okay if there's a little bit of compression there. What the idea is that you just don't want to lose anything, and you lose any potential volume from the bag as you compress. You want all of the compression here working for you and giving you a breath. And you can see how much more stable that is now too from before. So again, 6 inches wide or so. Find a nice location, draw your pencil marks, and tack it down. I do have a slight preference for having this further out this way, since your compression isn't perfectly flat like this. It is angled. So the less pinching you have on this side, the easier time you're going to have later. But by all means, support the bag to the extent that you can. All right, we're back now, and I want to talk about some motors since we're getting to that part. So here, I'm holding in front of the camera here, example of a motor that works for this application. This is a low RPM, high torque motor. This is a high torque application. And this particular motor, it says it's a DC 12 volts and 16 RPMs. You ideally want something that goes up to 30, maybe even 40 RPMs if you're talking about one rotation per breath. But certainly even something like this, which is like a 16 RPM motor, would be helpful. So certainly don't hesitate to build with something like this. But certainly you don't need anything more than 40 RPMs. 30 and down is fine. But the big limiting factor in this application is torque. So just be aware of that. When you're looking around for motors and shopping for motors, make sure you find something with enough torque. So this motor, obviously here's the shaft, and this is what attaches to the rotating arm, which we'll get to in a little bit. And here is a standard bracket that is sold along with these motors. And you're going to attach this bracket to the motor with a set of screws, like so. And then you're going to use these slots here to mount this on a piece of wood, basically. And here is one such piece of wood. So here we have a 2-foot length of 2x4 right here. And then this is connected at a right angle with a 12-inch length of 2x4. And what I've done here is actually just drill 2 holes in the top of this 2x4 and use zip ties to attach the PWM module. This is what will give you your rate adjustment. And your power supply is going to hook into here, and your motor is going to hook into the back here as well. There's a large range of PWM modules you can use for this. I'll go into more detail in the written parts list. But certainly if you have any questions about this, feel free to ping me. Nothing complicated here for connecting this. The 12-inch piece is connected to the 24-inch piece just with a couple of screws here. And the idea here is that this is going to sit something like this. All right, so here's your motor mounting bracket. And I wanted to show you the bolts that I use to attach the motor and the mount to the 2x4. So this is just a simple 1024 machine screw. This is 2 inches long. And at one end I have, and so this is, sorry, just to give some detail here, this is a flathead with a Phillips tip. And I've put in here a lock washer and a standard washer. You're going to want to put one in there like that. Get the other one. And one in here like this. And you put that on before you mount the motor because basically you're not going to be able to get to it after the motor is mounted. And so once you put those on, you can see here's one little screw that's included with your motor. And you're going to attach all this together like so. So the end product, once you put your mounting screws on, looks something like this. So these 4 screws here are obviously pretty critical. They're what hold the motor to the rest of the frame. So you want to torque these down pretty good. This is a place where if you have Loctite, Loctite's going to be your friend. So put a drop of Loctite on each of these guys before you tighten things up. In fact, another place where Loctite might be your friend, or where you at least want to make sure your screws are tight, or on the motor body itself. I forgot to mention this, so I'm going to mention this now. This is where, this is like this, right? So this is where the plate screws attach. On this particular motor, there's 4 small screws that hold the case closed as well. This guy's vibrating, it's going to be bouncing around. It's not a bad idea to tighten these down. And if you're so inclined, go ahead and take them out and put a little Loctite on those too. There's no need for you to be getting in here. You're not going to be maintaining the gears in here. But just make sure those are nice and snug. And the added benefit of mounting that plate is that those screws will be prevented from backing out as well because they're held in there by the mounting plate. So for the next step, I want to start talking about how we set up alignment of all our drivetrain elements. We've taken our 2-foot 2x4, which is screwed to a 1-foot 2x4, and stood it up vertically. Again, our PWM module is just zip tied to the 1-foot 2x4. And I'm just going to start by positioning it behind the bag, just like so, roughly in line with this mounting block, and maybe about 1.5 inches, inch to 1.5 inches between the mounting block and this 1-foot vertical 2x4. And I want this face of this 2x4 to be roughly parallel to that guy there, to the side of the base plate there. And then I'm going to take my motor and see if I can get this to line up right. So you can see, I'm going to take my motor here that we've mounted to its mounting plate and basically hold it against this vertical 2x4 here. And I want to align it such that the shaft of the motor is hitting the middle line, the imaginary middle line of that PVC compression arm. And once it's there, I'm going to mark off roughly where that machine screw, what level that machine screw is at, because that's where we're going to start drilling some holes. And just to note, if you've mounted your motor so that it's like this, and your motor plate is facing the other way, you're going to be like this, that's totally fine too. That doesn't matter at all. But what does matter, again, is that this shaft, you want to be roughly in line with the middle of that PVC compression arm. All right, so you've marked off the level of your machine screws as you've done your first sort of eyeball of where things are, and I've marked this off right here. Next step is to start drilling a bunch of holes, because these holes are going to be what give you vertical adjustment of your motor height in this direction. So this motor, I should add, is built in metric dimensions. So these machine screws on that mounting plate are actually 33 millimeters apart. So if I want to be able to marched this motor out and mounted it at different heights, I need to drill these holes into at intervals that divide evenly into that 33 millimeter number. And so obviously mixing English and metric makes me cry a little, but sometimes you gotta do that. So to start off with, I drew a line, which you can still see in pencil, about 1 inch from the edge of the 2x4. And then I made marks 11 millimeters apart. Again, because 11 millimeters divides evenly into 33 millimeters, so I can march that motor up and down as I please. And then you just take take your drill bit, something that will make a hole big enough for these machine screws, and march up and down, drill a bunch of holes. You don't need to drill as many as I have here, because this is a prototype. I just drilled a bunch to make sure I had enough space. You maybe need to go, not more than 10 in each direction. But it is important on this side at least to try to line things up well. Obviously, if you're drilling by hand, you don't have a drill press, that's fine. You're gonna get much worse alignment on the other side. You can see here I am not very good at keeping a straight drill bit at 90 degrees. But that doesn't matter much because you're just going to be tightening those things down with wing nuts anyway. So go ahead and drill those holes so you can make some adjustments. All right, so briefly, just to show you the alignment I was talking about, we've mounted the motor to the vertical 2x4, and we mounted it just using washer wing nut. Make sure you use washers here. You just have to have them there. It's not going to work very well without it. But again, show you that alignment here. You can see the shaft of the motor. It's coming out, and it's roughly meeting the midline of that PVC tube. Let me show you this angle. About like that. And you can see, at least on my setup, how that all lines up roughly. So the next step is to start making your rotating arm here. So for wood, I have here just some scrap I had lying around, but certainly anything like 1x2 would be about right. If you have a bit of molding that is in this rough shape, that's fine too. But the bottom line is you want something that's light, but also stiff and strong enough, because it's going to be, you're going to be pushing down a lot on that compression arm. So you want to make sure that can take that sort of compression. A yardstick isn't going to do it. Maybe if you had 3 yardsticks glued together, if you're stuck, that could do it. But single piece of wood is preferable here. I started with a 16-inch length of this wood, and then to that I have attached a flange. This flange is what's going to attach your rotating arm to the axle of your motor. The axle is going to go in there and then be held in place by the set screw. You see the hole there for the set screw. And that I just attached with some simple wood screws, nothing complex. What I've done next then is measuring from the midpoint of this piece of wood, start marching out some different radii, some rotational radii, which are, this one I think is like 5.5 inches and 6 inches, 6.5, 7 inches, something like that. And you can even measure out slightly different radii here to give you some way to tweak things so that you have a different set of distances on this side than you do on the other side. And then at whatever distance you have those, drill holes. Here I've used I think it's a 3/8 inch bit to accommodate my 5/16 inch bolts here. The reason why we use 5/16 inch bolts is because these skateboard bearings just slide right over. These are actually metric measurement bearings, but it just so happens that they slide nicely over the threads of these 5/16 inch bolts. So you want to get a couple of these bearings, at least 2 per bolt. And then what I've done here, just to get some space in between them, I've put nuts in between. So here we have bolt head going through fender washer, nut, bearing, nut, bearing, nut, bearing. And then here is actually a lock nut. You don't have to use a lock nut. You can use Loctite there, but you want something there that'll keep this from backing out, because you want to be able to leave this alone for a couple days, at least not think about it for a couple days. So you want to make sure that's snug down. All right, so here's what things look like assembled. So here we have the flange attached to the shaft of the motor. Get closer here. Now the little set screw that actually does the holding work here, that's a pretty critical screw, obviously, I have to tell you that. So this is where, again, Loctite is going to be your friend. We have Loctite on our motor mounting screws. This is a great place for Loctite too on that set screw. Make sure you crank that down, make sure you get that on there tight. And then we have our rotating arm here with our set of holes drilled at regular intervals. These guys are 1 inch apart. And our compression bolt. Next comes power, because you can't do anything without power. So what I've already done is taken the terminals from my motor here. This one was lucky enough to be pre-wired, but you can certainly, if you just have some bare terminals there, just attach some wire to them. Solder them if you need to. And I attached the motor to the terminals of the PWM module. So just to be perfectly clear, red goes on positive, black goes on negative. And then these terminals are where the power supply is going to connect. Power supply is here. This is just a standard power supply brick that turns AC current into DC. So what's nice about this guy, it takes 100 to 240 volts, so you could use this overseas if you need to, but it puts out 12 volts, as you can see here. I'm not sure if you can read that. 12 volts and 10 amps. This may be overkill. I actually haven't measured the amperage draw of this whole setup, but 10 amps is on the safe side, so I'd recommend that to start with. So this brick just plugs into the wall, and then on the other end, following that, this particular model has one of these connectors, and this is what you see plugging into laptops, into all manner of electronic devices. That fits into a connector like this. This power supply actually came with it, so these are nice to have, but if not, if you're stuck, you can just cut this, strip the wire, and then find the positive and negative wires in there. But what's nice about this guy is the green end here, you can actually chuck wires into there, clamp them down, and then you have an easy way of connecting to the actual power supply. Just a nice quick release there. So we'll get that set up now. With these wires, actually, I should talk about wires. These are 14 gauge wires, just stranded wire. You don't want solid wire just because it's a pain in the butt to deal with. It's pretty rigid. This stuff's a little more flexible. And 14 gauge is about the max that you're going to fit into these terminals here. So we'll get that set up. All right, so we're going to do a test run here. So you can see we have our, power supply connected to the wall. Coming across my mess of tools. Our 2 connectors here. So this is on the cord of the power supply. Then we have our female connector here with the 2 terminal connection points there connected to wires. That comes up to our PWM module, which is in turn connected to our motor. So we're going to give this a dry run just to make sure everything is working. Turn that on. There we go. And we'll turn our PWM knob just to make sure it is indeed controlling rate, which it is. Super slow. All right, onward. All right, now for some more alignment. Now when you compress this guy manually, there's actually a practical limit to how far down you can push this, because what happens is the bar actually pinches the bag enough where there's no more room to pinch against the base block here. So that's right about here. I mean, you can feel it when you do it yourself manually. That's about as far as this will ever push. Beyond this, you're not really getting much breath, and you're only just straining the system more. Short of finding a more clever way to compress this bag, that's probably about the max you can do there. Maybe if you slope this block a little bit, you get a little bit more, but we won't go into that too much here. So when I compress this to max compression, you'll notice that I've rotated the arm, my compression arm here, my rotating arm I should say, to where it's roughly perpendicular to the PVC compression arm at max compression. And so this is sort of the point of most strain, I guess, in the system. And this is an important point to measure and assess. And I'm looking at this and saying, all right, I need to make sure that the holes on my rotating arm make it out to here, and really no further, because further than this, I'm not getting any benefit out of this, just adding more strain to the system. But here I can see that indeed my holes are reasonably placed. I have control over the depth of my compression, depending on where I place my compression bolt. And I'm out far enough here, I've drilled holes out far enough where I can basically achieve max compression. There'll be a little more room here because of the bearing. So I think the system should be able to do this, and anything beyond this will be unnecessary. So that's what that eyeball exercise is all about. So the next step is to sort of hold everything together and see how things are working and whether your approximations are good. And so what I'm doing is nothing's bolted down here and under my left hand. I'm just holding it in place, and in the place I'm holding it, I want to see, is my compression bolt there, which you can see hitting the arm and rolling across it, is it maintaining good alignment on that PVC bar as it goes across? And it looks to be. If it wasn't, you could twist things around a little bit. You could even loosen your motor mount and rejigger that a bit. But you want to make sure that as you're going through that entire cycle, things are moving smoothly, and you move around to accommodate that. And again, just to show you, it's a little cold in the garage here, and I don't have my return rubber band set up yet, but let me give it a little nudge here. I'm going to push out the PVC bar. You can see that if the bar were, if the bag were fully inflated, I would still have that alignment between the axle of the motor, between the rotating axle of the motor and the center of the PVC compression arm. So I want to make sure that I maintain position as I'm checking everything. So if I'm happy with this, which I am, I'm going to mark off that position on the bottom there, and actually going to screw that down so that we don't get a lot of movement. Before we bolt everything down though, I wanted to go back to this end and show you some of the detail bits here. Let me move my motor out of the way. Crash. All right, so you see how when you compress this arm, a lot of times you don't get full return. You can still see the little dent there. You don't get full return of the PVC compression arm to full height. And so to help that, I've put in some cup hooks here. You don't have to use cup hooks, but any kind of hooks are fine. And to these, I attach rubber bands, usually doubled up. And what this does, this is hard to do one-handed because I'm holding the camera, but what this does basically is it gives you a little bit of extra lift such that, or so that, your PVC compression arm can return all the way up. It's important that you get this all the way back up because if it's not all the way back up, you're actually losing efficiency. You're losing that bit of compression, that bit of volume that you otherwise would have had here. And this is, frankly, the easiest place to get volume for your compression. So you want to make sure you have that because that's just easy returns there. So simple enough, just screw in some hooks, get your rubber band there, and that'll help bring things back up. You don't want to go crazy here with this rubber band. You don't want to have like 4 or 5 or something really thick because that will make it harder on the motor to compress that. You just want enough to get full return of your PVC tube here. And another thing you might see here, those of you who are keen-eyed, I've actually wrapped the bottom bit of this tube, the PVC compression arm, in Teflon tape. Plus, because you can get some squeaking and some friction between the bag and the PVC compression arm. I'm not sure if this makes much of a difference, but it's easy enough to do. Teflon tape is super cheap, so just wrap it around, tape it down, and yeah. So that's just 2 detail items on this side. Hey friends, we're back. Everything's been assembled, as you can see. I've actually hooked things up to our fake lung circuit here, just so we can get a little resistance in the system, since that does matter. I'm actually stress testing this now. That's something I recommend highly to all of you after you assemble one of these puppies. Just to take a step back though, in the course of assembling ends up that my particular setup has a PVC pipe riding between the second and third bearings as opposed to first and second. Fine, no big deal. Gosh, what else? For the sake of the stress test, I've done a couple things. I've actually moved the motor down a little bit. So if you'll notice, let's see. We'll let this go around. I'm going to hold this down. And what I'm feeling now is actually I am about at this is like maximal compression here. This is probably a little bit more than I would want it to be, in fact. And when I'm here, I can see and feel that the bearing's actually touching this. So in fact, the setting that we're at right now is a little super maximal, a little further down, more compression, more torque than I would otherwise want it to be. But that's fine for stress testing. That's what we want. And I accomplished that again by moving the motor down a couple holes. In addition, I've added a second rubber band to the little rubber band triangle here. Again, that adds a little extra resistance to the arm as the compression bolts come around and everything rotates. And so all that is translating back to more torque here. This guy is running pretty hot. But again, we want to stress this out. We want to see how this runs. I recommend this again highly for any of you putting one of these together. Do at least a 24-hour stress test. We know that people are on vents for days at a time in the COVID situation. So we want to be sure that one of these guys, if we get to a position where we're relying on one of these, can be counted on to keep on going for that period of time. So please do a good stress test. Beyond that, I think that's all there is. I'll have a couple short videos also posted to the channel about how to adjust things like toggle volume and how to adjust INT ratio. But as built and as tested, which is pretty much as it is right now, minus the sort of super maximal settings, but as built, basically, we're talking about tidal volume 450 to 470 mils and an I to E ratio of 1 to 2.7. So physiologically useful settings. I guess I'll leave it at that. That's a wrap for this video. Thanks for watching. If you have any questions, please contact me. I've left my email address in the comments, so please don't hesitate to reach out. And if you have comments or other suggestions, again, those are most welcome. And be safe out there, folks. Take care.